She has published more than 50 papers and she has presented many papers in national and international conferences. So I would like to, Rashmi Madam, please deliver your lecture on pesticides. Thank you.
Thank you, Qasim sir, for giving this opportunity to me. I'm Dr. Rashmi Urukude. Actually, I'm blended my talk with some social issue in addition to chemistry. As we know, most of the people depend upon agriculture. And when agriculture is there, pesticide is there. So what do you mean by pesticide? The pesticide means any substance intended for preventing, destroying, attracting, repelling, or controlling any pest during production, storage, transport, distribution, and processing of food and agriculture commodities. So actually pesticide has very broad spectrum. It is very broad term. What people think pesticide is insecticide which used to control the insect, but it is not so. Pesticide includes insecticide used to control the insect, fungicide for fungi, rodenticide to control the rodents, nematicide to control the nematode, then molluscicide for mollusca. Plant growth regulators also come under the pesticide, which accelerate or retardation of growth of plants will be there. Then defoliants cause the plant leaves to die or fall away. Attractants which attract the pest, and repellents to repel the pest. All these are included under pesticides. So the pesticide, it is very broad term actually. Now, why we are going to use the pesticide? Why we are using the pesticide? The reason for using the pesticides are to ensure better production at harvest against unpredictable losses caused by pest, to improve both quality and quantity of food, to decrease the extent of vector-borne diseases. And for this reason, we are using the pesticides. हमें याद होगा या फिर हमारी नानी या फिर हमारी दादी जो थी वो क्या करती थी कि नीम के लीव्स जो नीम के पत्ते रहते थे वो अपने साड़ियों में रखती थी, सिल्क के साड़ी में. इन एडिशन टू दैट जो स्टोर्ड ग्रेन रहते थे उसमें भी वो नीम के पत्ते यूज़ करते थे. सो दैट वेयर द नेचुरल सोर्सेस. एट दैट टाइम that weeds were controlled by salt, copper sulfate used to control the fungus. Some flowers like a pyrethrum were also used as pesticides. But the drawback of these compounds were, iske drawback kya the? High rate of application and lack of selectivity. High rate of application and lack of selectivity. And thus, there is an invention of synthetic pesticide due to the lack of selectivity for natural sources. Then the high amount of pesticide actually botanicals will have to use. And to overcome this drawback, the synthetic pesticides have been invented. Now, synthetic pesticides accelerated in 1940 with discovery for so many chlorinated hydrocarbon, among which DDT, that is dichloro-diphenyl trichloroethane, was first synthetic pesticide discovered to control malaria by Dr. Paul Muller, chemist from Switzerland. In 1949, he got Nobel Prize in medicine. Actually, he invented the pesticide and he got Nobel Prize in medicine. Now, these pesticides are basically classified as botanicals and chemical pesticides. As we know, the chemical pesticides are widely used. Again, they are further classified into inorganic pesticide and organic pesticide. So, this organic pesticide again classified into 4 major classes: organochlorine, organophosphate, carbamate, and pyrethroid. ठीक है, नहीं है तो यहाँ से स्लाइड कर देंगे. ठीक है, मैं ही कर लूँगी. Okay, organic pesticides and inorganic pesticide. Again, they are classified into these 4 major classes. You will get the different example of these different classes. Organochlorine, then that is the chlorinated hydrocarbon, organophosphorus compound, then carbamate compound, then pyrethroid compounds are there. Actually, ideal pesticide, it should have the following properties. It should have broad spectrum to kill the pest. It should be non-toxic to mammals. It should be non-toxic to plants. It should have low production cost. खर्चा कम आना चाहिए. It should be easily formulated. जो formulation बनाते हैं हम active ingredient से, तो it should get easily formulated. It should have optimal residual persistence. Residue कम से कम रहना चाहिए. It should have low toxicity to beneficial insect. It should compatible with other pesticides. Sometimes what happen, 2 pesticide जो 1-2 pesticide mix करके 2 या उससे ज़्यादा भी pesticide mix करके spray करते हैं. At that time the compatibility of pesticide should be there. It should not produce off taste on vegetables on which it is sprayed. It should be non-flammable and it should have non-corrosive action on metal. It is from a storage point of view. It should be non-flammable. At the same time, it should not be. It don't have the corrosive action. आपने बहुत बार न्यूज़पेपर में पढ़ा होगा. Such type of news बहुत बार न्यूज़पेपर में आती है कि you can see here 9 district in grip of pesticide poisoning. ये जो second news है उसमें आप देख रहे हो. The EU has objection to excessive presence of pesticide from India. 70% of grape exports are to the EU from India. मतलब due to presence of pesticide, so many export consignment get cancelled due to the presence of these pesticide residues. मैं आपको एक वीडियो भी दिखाना चाहती हूँ. बड़ा ना.
A train that patients climb onto from Bathinda to disembark at Bikaner for much cheaper treatment. No AC coach, only sleeper class, first come, first serve. But as the clock approaches 9:30 p.m., those familiar with the train knew how to find a berth first.
जो ठंडा पानी पींदा सी ना वो वापस आंदा सी वापस लो तो बाद जो टेस्ट होया ਸਾਨੂੰ ਉਸ ਤੋਂ ਬਾਅਦ ਪਤਾ ਲੱਗਿਆ ਫਿਰ ਅਸੀਂ ਉਸ ਤੋਂ ਬਾਅਦ ਤੋਂ ਇਲਾਜ ਸ਼ੁਰੂ ਕਰਵਾਇਆ
But first stage cancers.
ਹਾਂ ਬੋਤਲਾਂ ਲੱਗ ਗਿਆ ਬੋਤਲਾਂ ਨਾਲ ਠੀਕ ਹੋ
Chemotherapy लगी.
ਹਾਂ ਕੀਮਾ ਲੱਗੇ ਸਿੱਕਾ ਨਾਲ ਅਸੀਂ ਟੋਟਲ 15-16 ਵਾਰੀ ਜਾ ਆਏ
एक साल.
1 ਸਾਲ 20 ਦਿਨਾਂ ਬਾਅਦ ਜਾਂਦੇ ਜੀ ਹਰ 20 ਦਿਨਾਂ ਬਾਅਦ
Randir Singh travels to buy chemotherapy medicine for his wife and friend, both cancer patients.
Actually sound is not clear. ये जो वीडियो है ये it is for the cancer train. जो भटिंडा से बीकानेर जाती है वहाँ पे 60% जो लोग जाते हैं they all affected with the cancer and therefore it is known as the cancer train. तो it is from the Punjab actually. Bhatinda it is in Punjab. तो ये कैंसर ट्रेन इसको क्यों कहा जाता है और why these things are happening over there? So it is happened due to injudicious indiscriminate use of pesticide. ये जो pesticide residues आते हैं it is due to injudicious indiscriminate use of pesticide. So what do you mean by injudicious and indiscriminate use of pesticide? Excess use of pesticides, use of non-recommended pesticide, no consideration of need-based application, and ignorance of waiting period after application of pesticides. All this comes under injudicious and indiscriminate use of pesticide. So, What do you mean by pesticide residues? Pesticide residues are the deposits of pesticides in food and some component of environment after its application. So what do you mean by pesticide residues? Pesticide residues are the deposit of pesticides in food and some components of environment after its application. But pesticide contamination in food and vegetable is regulated through concept of MRL. So what do you mean by MRL? It is known as the maximum residual limit. So MRL, it is residues of pesticide may remain in crop produce and get into human food chain. This residue should not exceed a limit above which they may pose risk to human health. These residues, this sentence is very important. These residues should not exceed a limit above which they may pose risk to human health. So, a little is good, lot more will be better, but it is not true with the pesticide. A little is good, lot more will be better. So, this injudicious and indiscriminate use of pesticide ultimately results into the pesticide residues and it comes to your plate. Now, ill effect of these pesticide residues. You can see here, there are many pesticides I have enlisted over here. They cause the nerve damage, DNA mutation, hormone disorder, neurotoxicity, then liver damage, developmental, reproductive damage is also there. It causes the cancer, infertility, developmental and neurological damages are also there. It affects the nervous system, lungs, liver, kidneys, eyes. Okay, so these are the ill effect of these pesticides. So actually this slide I have taken just 2 days before. This survey, it is published in the newspaper of Nagpur, that is the local paper of Nagpur, that is the Hitwada, that is the English daily. They have published that the surveys over there, the vegetable in the supermarket containing illegal pesticides and excessive pesticide. Here you may observe that only 40% of the sample are we can consume or they are considered as a safe for the consumption. 62% of the sample is safe for the consumption and the rest of the 40% is containing, about 40% of the sample is containing illegal pesticide. In addition to that, the sample exceeding the pesticide maximum residue limits. Means this 13% and 25% collectively it is about 40% and 40% of the sample are not, we cannot use for the as a eatables. So because they contain the illegal pesticides and in addition to that they also contain the pesticide above the MRL. If pesticides are there, there is no issue, but it should be in a within limit. It should not exceed the maximum residual limit. In this diagram, you can see that only 62% it is okay, and the 40% we have to reject that sample actually from the consumption point of view. Now the different pesticide have the different MRLs for the different commodities. It is the agriculture commodity. For coffee beans, in case of leuphoneuron, it is 0.07. In case of cucumber, it is 0.09. For lime, it is 0.4. For maize, it is 0.01. For potato, it is 0.1. And for oranges, it is 0.3. And for tomato, it is 0.4. Nagpur is known as the orange city. So most of the export is of oranges from our Nagpur. And if it is exceed than 0.3%, we cannot export such type of consignment or such type of oranges which contain the more than 0.3% of leuphoneuron. It is in case of Ethion. The spices are there, commodity is spices, but for fruit and berries, the MRL it is the 5 ppm. For spices, in case of spices, the root and rhizomes are there. For this, it is 0.3. For seed, it is 3 ppm. So for different pesticide, the MRLs are different. It depends upon the commodity, it depends upon the pesticide. You may get the chart of this MRL on the internet. Different pesticides are there and different MRLs are given there for the different commodities. Now, pesticide use in different country. In our India, only 3% pesticide is used, even though we are facing the issue of pesticide residues. So, pesticide residue problem can be minimized. How we can minimize this problem of pesticide residues? Need-based application of pesticide should be there. Proper selection of pesticide should be there. Proper time of application should be there. Proper concentration in spraying should be there. Then proper technique of application should be applied. Then use of recommended pesticide, again target paste. We have to use the recommended pesticide. Consideration of waiting period after application. One must observe the waiting period after application of the pesticide. Now, in this slide, I can say pesticides are safe when used properly. This is awareness program organized by our college student for the farmers, where they disseminated the information about how to use the pesticide. Being a person of chemistry, they disseminated the information about how to prepare the proper suspension of spray liquid. Most of the farmers क्या कहते हैं, एक बकेट में पानी ले लेते हैं, whatever quantity they require, वो उसमें डाल देते हैं, फिर वो स्प्रे जो करते हैं, वो स्प्रेयर में knapsack sprayer is there, उसमें वो डाल देते हैं and they start spraying. वो उसका होमोजेनाइज मिक्सचर बनाते ही नहीं, मतलब ऊपर ऊपर के पार्ट में पेस्टिसाइड चला जाता, मतलब अगेन इट विल बी द एक्सेस यूज ऑफ पेस्टिसाइड और बाकी इसमें पूरा पानी छिड़का जाता है. सो दे मस्ट बी अवेयर अबाउट दिस टेक्निक, हाउ टू स्प्रे द पेस्टिसाइड एंड हाउ मच क्वांटिटी ऑफ पेस्टिसाइड शुड बी यूज्ड एंड विच टेक्निक इज यूज्ड फॉर स्प्रेइंग द पेस्टिसाइड appropriately. These are our students. They every year we organize such type of program. Actually it is under the extension activity. हम जो कुछ भी करते हैं तो हमारा कुछ सोसाइटी के लिए भी काम होना चाहिए. Whatever our research is there, it should be applicable for the society as well. Therefore our student organize such type of awareness program every year for the farming community. और सही में जब हम जाते हैं तो उनको पता ही नहीं रहता कि कैसे सस्पेंशन बनाना, कौन से पेस्टिसाइड यूज़ करना, किस तरीके से स्प्रेइंग करना. तो ये सब अवेयरनेस प्रोग्राम का उनके लिए बहुत फ़ायदा है. सो एवरी ईयर वी ऑर्गेनाइज सच टाइप ऑफ अवेयरनेस प्रोग्राम अंडर द एक्सटेंशन एक्टिविटी. सो दिस पेस्टिसाइड कैन बी डिटरमिन्ड इन लेबोरेटरी. सो two major parts are there. One is the sample preparation and another it is the analysis. So this Quechers method, it is applicable for the sample preparation. Before subjected particular sample for the analysis, we have to prepare that sample appropriately. So this Quecher method, it is the modern method which is used for the sample preparation. So it is quick, easy, cheap, effective, rugged and safe method. Collectively it is known as the Quechers method. So it is the just a flow chart which is the very basic Quechers method, where we have to take the 10 gram of sample, then we have to add 10 ml of nitrosyl, then again we have to shake that, we have to add some salt. Addition of the internal standard, we can skip that step. Then we have to take the alicate and we have to add again salt and primary secondary amines to that. Then we have to shake it vigorously and finally it should be subjected for the chromatography analysis. So this is the pictorial presentation of this Quechers method. So initial extraction step, we have to take the 10 gram of sample. First we have to mix that under the, जो हमारे घर में मिक्सी रहती ना, वो उसी तरीके से मिक्सर से हम उसका होमोजेनाइज एक मिक्सचर बना लेते. Then we have to take the 10 gram of sample. In that we have to add 10 ml of acetonitrile, which is act as a solvent, extraction solvent करके काम करता है. Then we have to shake it intensively for 1 minute. That test tube should shake intensively for 1 minute. After that, we have to go for the partitioning step. इसमें क्या करना है, वो जो पहले वाली जो टेस्ट ट्यूब है, उसमें ही हम 4 ग्राम ऑफ MgSO4 ऐड करेंगे and we will add 1 gram of NaCl. Then again we have to shake it vigorously. इससे क्या हो जाता है, whatever moisture is present, we have to remove that moisture by using this salt. Then addition of internal standard, we can skip this step and then we have to go for the centrifuge. इसको centrifuge करेंगे for 5 minutes. We will get separated raw extract. You can observe over here, alicate is there. It is the separated raw extract. Now we will have to go for dispersive SPE step. That is solid phase extraction step. Here we have to add MgSO4 salt and PSA. PSA will act as a cleaning agent, primary, secondary amines. Again we have to shake it for 30 seconds. We have to centrifuge that for 2 minutes. We will get clean up extract. मतलब बस 10 ml जो हम solvent use कर रहे हैं, मतलब हमको initially कितना sample लगा, just the 10 gram of sample is required. We have added only 10 ml of acetonitrile, मतलब very small quantity of solvent is also required over here. In addition to that, very small little time is consuming over here. बहुत कम, very in a short period of time, we can proceed with this extraction. And for this cleanup, we have to add the primary, secondary amines. We will get the alicate, which is very clear and clean extract is present over there. And after filtration, we can subject it for the chromatography analysis. So this is multi-residue analysis. After that cleanup and extraction, we have to subject that sample or extract to the chromatography. You will get such type of beautiful pics over there. This is the multi-residue analysis. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 12 pesticides are there. So we can identify these 12 pesticides. So this is the multi-residue analysis. So you can see here also. This is also multi-residue analysis. So why quechers? Why nowadays, why this quecher is recommended? ये क्वेचर मेथड अभी रेकमेंड क्यों की जाती? पहले हम क्या करते थे, सॉक्सलेट एक्सट्रैक्शन से हम एक्सट्रैक्शन करते थे, तो दैट वाज टाइम कंज्यूमिंग. इन एडिशन टू दैट उसके लिए बहुत सारे एपरेटस लगते थे, बहुत सारा सॉल्वेंट लगता था. बट बाय दिस क्वेचर it has a great advantage. Sample preparation is extremely important part of analysis program. Many times sample contains dirty matrices which can interfere with analysis. It is very important that the matrices are removed by proper sample cleanup produces before the sample is introduced into chromatographic system. There are various methods of sample preparation, but many of them are time consuming and utilize large amount of solvent. जैसे मैंने बताया था कि पहले हम सॉक्सलेट एक्सट्रैक्शन से काम करते थे. Now we are going with the quechers method. So quechers is simple method developed for efficient sample cleanup. It is extraction and cleanup technique, especially for pesticide residues from fruits and vegetables. ये टेक्निक जो है वो एक अमेरिकन साइंटिस्ट है, उन्होंने इन्वेंट किया है. So it is a very simple, rapid, effective yet inexpensive way to extract the pesticide residues. So there are many papers which are published on the quechers. You may also get my paper which is published in the elsewhere. So you can put my name Rashmi Urkude, you will get that paper. That is also published on the quechas. Now, the minimization of pesticide results into minimization of environmental pollution. It minimizes health hazard. Now, the chances of export consignment cancellation get reduced. Pesticide residue agar minimize ho gaye, if it is under the maximum residual limit, then the chances of export consignment cancellation get reduced. We can easily export our consignment to the foreign countries and ultimately result into inclining the economy. सारी बातें घूम फिर के इकोनॉमी पे ही आती है. If आप हमारा अगर एक्सपोर्ट बढ़ जाता है तो obviously the inclination of the economy will be there. So about the pesticide, I can say think first and spray last, because one should not go with the injudicious and indiscriminate use of pesticides. So we have to think first, and finally we have to go for the spraying of pesticide. Okay, so this is all about my presentation. The next things are also there, but due to time constraint, I'll stop over. Any question from your side? Actually, it is it have the social aspect to this topic. So मेरा भी आपको सबको अपील है फॉर स्टूडेंट, वट एवर यू आर डूइंग, आप बहुत सारा सिंथेसिस करते हो, सिंथेसाइज करके उसका कैरेक्टराइजेशन करते हो, कैरेक्टराइजेशन करके आप क्या करते हो, यू पब्लिश द पेपर और वो अपने साथ रख देते हो. बट इट शुड हैव द एप्लीकेशन फॉर द सोसाइटी. जो कुछ भी आप रिसर्च कर रहे हो, इट शुड बी यूजफुल फॉर अवर सोसाइटी. अब जो PhD के बच्चे अभी कितने हैं, आई डोंट हैव दैट आइडिया, लेकिन आप अभी आगे जाके यू मे गो इन द टीचिंग फील्ड, तो जब कभी आप प्रोजेक्ट वगैरह लिखते हो तो वो देखते हैं कि वेदर योर प्रोजेक्ट हैव द एप्लीकेबिलिटी पर्टिकुलरली फॉर द सोसाइटी, तो आपको इजीली फंडिंग मिल जाता है. ओके, सो एनी क्वेश्चन फ्रॉम योर साइड? द क्वेश्चन आर मोस्ट वेलकम. ओके, थैंक यू वेरी मच फॉर योर पेशेंस.
If there is any
listening.
participant online, do you have any question, please ask. Okay, thank you, ma'am. Thank you so much. So, we were listening Rashmi ma'am, Professor Rashmi ma'am. Ma'am is going to chair this session, and next we are going to invite the participants to present their work. Okay.
We'll start with the presentation of Muhsina Ahmed. Muhsina Ahmed. First presenter name is Muhsina Ahmed.
Good afternoon, ma'am.
Are
Am
you
I
ready
audible?
with your presentation?
Yes, my presentation is ready.
So please share your slides.
Okay, sure, ma'am.
Before the presentation, I would like to request all the participants, please prepare your slides and be ready for the presentation.
My topic, advancements in water purification, green synthesis of pineapple peel derived iron manganese binary oxide magnetic nanoparticles for efficient methylene blue removal. First one is the general introduction. As you all know, water pollution is one of the main problems the world is facing today due to rapid industrialization and economic growth and various other reasons. The main pollutants are dyes, heavy metals, etc. And the dyes are one of the easily visible ones, and they are very harmful due to their toxicity, and they are carcinogenic also. There are various methods present today which we can use for the removal of dyes, like chemical precipitation, coagulation, etc. And adsorption, we have found that it is one of the best one because it's easy, it's versatile, and it is cost effective. Next one is the materials and methods that we have used. First one is that we have prepared is the ferric chloride magnetized nanoparticles. For this, we have used a two-step technique in which we use precipitation as the first step and hydrothermal method as the second step. In the first step, we prepared the nanoparticles in which we took 2 grams of ferric chloride and 4 grams of ferrous chloride and dissolved it in distilled water. And then we stirred it for about 1 hour, and then we added 2 egg whites, and this was done to decrease the size of the nanoparticles. After that, for 4 hours, the mixture was heated, and then ammonium hydroxide was added to it, and the ferric chloride particles were formed, which were separated using centrifugation, and they were washed several times with distilled water, and then afterwards they were washed with ethanol. The black residue was oven dried for at 70 degrees Celsius for about 12 hours, and then they were kept in a muffled furnace at about 700 degrees Celsius for 6 hours, and then they were lastly these were prepared and kept for further use. The next step was the ferric chloride nanoparticles were added to potassium permanganate to prepare the other adsorbent. And in the last step, the pineapple peels powder was added. Lastly, which was the last step in which our adsorbent was prepared. Next is the results and the discussion one. These are the SEM analysis which was done in the first A1. We can easily see that the adsorbent has various pores available for the dye adsorption. And in the next one, that is the B1, the pore, we can easily see that the pores are filled. The next slide contains the TAM analysis, in which we can see that the particles were rod shaped, and these were of nano range. The ranges are also given there. The next slide is that of XRD analysis, in which we can see that the ferric chloride and the pineapple peel manganese iron binary oxide nano composite were having the same peaks. That means the peaks were not different, and the shape of the crystals is the same. Next is the FTI analysis, which shows the different peaks of the surface, the groups that are present, that are hydroxyl group and the other groups which are responsible for the efficient adsorption of the dye. Next, we had done the batch adsorption studies, in which the first one is the effect of adsorbent dose. In the first, we increased the adsorbent dose. On increasing the adsorbent dose, the adsorption efficiency also increases. Next is the effect of pH. On increasing the pH, the removal efficiency increases. Next is the effect of contact time. On increasing the contact time, in the first initial 15 minutes, the removal efficiency is increasing at a very steady state.
Monisha, come to your conclusion, because you have prepared 16 slides and it is only on, right now you are only on 11th. So
okay,
go with the conclusion.
Next, I have done the adsorption kinetic studies, in which we had seen that this follows the pseudo second order, and then afterwards we have done the adsorption isotherm study, in which we had seen that the best followed model is Langmuir model, and we had also done the desorption studies. The adsorbent is useful for about 5 cycles, and this is the conclusion. The same that I have already explained. The best desorption was done by hydrochloric acid. Thank you, ma'am.
So thank you very much for your presentation. Anybody want to ask question? Online, offline? So Langmuir or Friendlich, which one is more suitable for this method? How you can say that?
The R square which we found was near to 1, more near to 1.
Okay. Okay. Thank you very much. Now the next participant is Priyaza.
Yes, ma'am.
Are you ready?
Yes, ma'am.
So share your slide, please.
Mosina needs to stop sharing. Yeah.
Okay, I've done.
Thank you. Thank you. Good afternoon, everyone. Myself, Priya Jha. I'm doing my PhD from Guru Gobind Singh University under the supervision of Professor Kapil Jain. So the topic of my poster is synthesis of biometal organic framework coated on magnetic nanocomposite for drug delivery and other applications. So here I'm showing, I have tried to synthesize iron oxide and manganese oxide as a core, as a magnetic core, and then coating polydopamine on it and constructing a curcumin zinc MOF. So MOF are basically metal organic frameworks. They have already been used it's been 2 decades. They have been used as nano carriers for carrying the drug towards the cancer cells and in other diseases as well. So the basic reason for drug narrow carrier that it can work is this, as you can see, I'm enlarging. So this is a normal tissue and this is a malignant tissue, that is cancer. So in normal tissues, the vessels are completely blocked and aligned. So everything is systematic, but in case of cancer cells, the nerves have blockage, the nerves have breakages because there is a lot of demands of oxygen and other nutrients in these cancer cells that they increase the vasculature system, number of vessels increase. So there are breakages in this lymphatic and blood vessels. So there are a lot of pores. So when a nanocarrier is going towards them, so it's very easy for them to get into the pores and get in the vasculature structure of cancer cells so that they can accumulate in these cancer cells. And with this, if they are getting accumulated, we can use them in theranostic as well, in therapy as well, and as well as in diagnostic of the cancer cells as well. So as we know, my MOF is basically based on zinc, that is metals, and the organic linker here is a pharmaceutical agent, that is curcumin. So together it's a very good bioactive. It has been already used in it has been already studied. So first of all, I am synthesizing a magnetic core that is containing iron oxide and manganese oxide, and then I'm coating it with dopamine layer, and then I'm constructing curcumin zinc on it. And here the main reason for using this polydopamine is that this curcumin zinc is not that polydispersible, but when we are coating this iron core with polydopamine, it increases its polydispersity in water, and it is a very easy self-polymerized, it gets self-polymerized under alkaline solutions, so where it's easy to make. And here I have shown some of the analysis that I have done, that I am having activity images of the curcumin and zinc have a peak at 5. This is very big here in the image, but there are good peaks of these iron oxide and manganese oxide that have already matched with the Miller indices. And this is my TEM image that I am showing. The first one is the composite image. The second one is with the coating. Actually, the size variation in this one composite and the other image, second image of the TEM image, is because the iron oxide and manganese oxide are nanocomposite and they agglomerate before the coating of polydopamine. So they are in form of microspheres. So I can say magnetic microspheres, I can say. So it's a little bit dark there. And the last one is MOF. I have even done the UV, and we can see the peaks of these UV. Here we can, I have synthesized iron oxide individually and manganese oxide individually. Then I have synthesized them in presence of both of the precursors and then coated it with polyamine and then coated them off. So I can compare individual peaks there. I have I kept the MOF that I have made in different pH solutions, like 5, 6, and 7, 8 pH solutions. As some, actually, when I was in the initial, so there were some questions that how can you say that your your composite won't degrade in low pH? The thing was, when I did the same in different pH solutions, the curcumin complex, the curcumin is known to dissolve in alkaline solution, but it's not known to it doesn't break in acidic solution. But when it forms a complex with zinc, it gives a very good yellow color in low pH. That is the same pH in cancer cells, that is glucosic. And the same I've done with iron oxide and manganese oxide. So they don't show any peak distinct color in this. Then these are the synthesized nanocomposite that I have synthesized, and in presence of magnet and after without magnet and in presence of magnet. So we can see that it is showing good magnetizations here. So right now the research is already going on, and I have collected
Priya, please
that's
conclude.
right.
Please conclude yourself. Your time is
And
up.
it's in vitro study is still going on. So once I have it, yeah. So this MOF is believed to have these are in different parts, but it's believed to have R1 R2 relativities, so that it might be a good agent for MRI, as it can
Madam,
be used as a good
please,
MRI.
please come to
And
conclusion
because
only.
it is having a magnetic core, we can use this magnetic core for local heating. It gets accumulated in the cancer cells. It can
Your
be
time is up. Priya, your
cells.
time is up. So please conclude
Sorry?
yourself. Your time is up.
Yeah. I am on the conclusion. So when it's in the cancer cells, so
Conclude it in nutshell. Conclude it in nutshell.
okay. So these will help in T1 and T2 MRI imaging as well as a therapy for cancer, and to carry the chemotherapy drug like doxorubicin, paclitaxel to the desired cancerous cells. Thank you so much.
Thank you. Thank you for your presentation. Any question?
Yes.
How you have tested your drug for the cancer cell?
Ma'am, actually, research is still going on. I haven't reached that stage of in vitro and in vivo. I have just synthesized the MOF, and we are the process is ongoing for this. Right now, we are thinking of doxorubicin, using it. So still some of the analytical results are pending.
Okay. Thank you.
Thank you so much. Thank you.
Now, the next presenter is Raghavan Chandrasekhar.
Very good afternoon, everyone. Myself, Raghavan, a research scholar from the Department of Biosciences and Bioengineering, IT Guwahati. So today I'll be presenting my work entitled Hierarchically Porous Hydrochar derived from catalytic hydrothermal carbonization, the removal of multi-emerging contaminants. So coming to the introduction, we all know that water quality is greatly affected by many contaminants, including disease-causing microorganisms, synthetic chemicals, organic pollutants, and other toxic heavy metals. So among these contaminants, emerging organic contaminants are class of contaminants which are extensively detected in various environments due to their extensive usage, which includes pharmaceutical and personal care products, plasticizers, flame retardants, PFAS, and endocrine disrupting chemicals. So obviously they cause harm to the human health and also affect the ecological equilibrium. There comes the urgent need for customized treatment technologies to remove these contaminants. So hydrochar is nothing but a carbonaceous material synthesized from hydrothermal carbonization. It can be considered as an alternative for activated carbon. So due to the following reasons, like it has a lot of advantages, like which includes low synthesis temperature. Actually, activated carbons are synthesized at high temperatures as high as like 600 degrees Celsius. But hydrothermal carbon can be synthesized in low temperatures at the range of 180 to 250 degrees Celsius. And also it has a lot of oxygen containing functional groups. Along with that, it does not really release any toxic gases like methane and carbon monoxide. These gases are usually released in pyrolysis process, but in the case of hydrothermal carbonization, these gases are not released. So we opted to synthesize carbon from hydrothermal carbonization. So we opted to use the synthesized hydrogen in the adsorption. So basically, the advantage is like we can remove simultaneously like more than one contaminant, and also there won't be any secondary contamination in the case of adsorption. So we opted for adsorption, and also the selectivity of whichever adsorbent we choose, the selectivity will vary with respect to its physicochemical property and also the properties of the contaminants. So we decided to address those knowledge gaps in this study. This of our hydrothermal carbon. Then we synthesize the hydrothermal carbon using catalytic hydrothermal carbonization. So using muriatic acid as a catalyst. And then we also did other kinetic modeling and multi-component modeling to study the behavior of the adsorbent in multi-component adsorption. So coming to the characterization study, on the sawdust only contained in the figure A, you can see fissure surface of sawdust with fissures. In the figure B, it is hydrochar or synthesized hydrochar with the porous surface, and figure C is the close-up image of the hydrochar where we can see the formation of secondary char. So coming to the XRD analysis, in the sawdust, we could able to observe crystalline peaks of cellulose. So after hydrothermal carbonization, the cellulose got disrupted and we couldn't find any crystalline peaks. In the Raman analysis, we could able to observe multiple peaks of lignin, hemicellulose, and cellulose. But after hydrothermal carbonization, only 2 peaks we could able to observe. So those peaks are due to graphitized structure of carbonaceous material we synthesized. And other peaks.
Your time is up. Your time is up.
Yes.
Please come to conclusion.
We assessed the performance in binary and ternary systems. So we observed maximum removal efficiencies of 92% for ibuprofen, 85.4% for sulfamethoxazole, and 82% for bisphenol A. And we also tested the adsorbent in the humic acid environment. It is a naturally found organic compound, and it also had an insignificant effect. So which proves that our adsorbent can work in the real-time environment also. And also, in terms of selectivity, ibuprofen had the highest affinity towards the adsorbent. The reason was it was the most hydrophobic compound in the list. So the hydrophobic interactions could have dominated the other interactions and made ibuprofen more selective than the other contaminants. Other than that, diffusion dependent rate limiting step was intraparticle diffusion in the case of sulfamethoxazole, and in the case of bisphenol A and ibuprofen, it was liquid film diffusion.
Thank you.
And we found that interaction were happened in the.
Thank you. Please stop. It's more than 6 minutes now. Okay, any question? Okay, thank you, Raghavan. Now, the next participant is Amruta Gautam Salve.
A very good afternoon to each and everyone present over here. My name is Amruta Gautam Salve, and I am a research scholar from Dr. Babasaheb Ambedkar Marathwada University. I am very grateful to Maulana Azad National Urdu University for allowing me to present my paper. The topic of my presentation is biological and biosynthesis of antibacterial activity of silver nanoparticles using aqueous extract. So as we all know that nanotechnology has progressed a lot, and it has been a boon to mankind because of its special characteristics like finite size, the catalytic properties, specific surface area, etc. As we can see, we have many applications of nanotechnology like in the field of agriculture and food, electronics and so on. When it comes to the synthesis of these biological, of these nanoparticles, there are various methods, majorly such as chemical, physical and biological. But my work specifically focuses on the biological synthesis to make it more cost efficient, make it cost efficient, eco-friendly, and less toxic, less hazardous for the environment as well as for the human health. When we talk about biosynthesis, it means the green synthesis of the nanoparticles that are synthesized from the environmentally present components like microorganisms, algae, fungi, bacteria, etc., or any part of the plant like stem, leaves, flowers, etc. As we can see in this slide, the biological synthesis has been done using microorganisms and plant tissues, and there are various applications. My work mainly focuses on the green synthesis using Saraka Asoka leaf extract. So, I have done the synthesis by collecting the dry leaves, by collecting the leaves of Saraka Asoka plant from my college, Maulana Azad University, Aurangabad. And from there, I collected the plants, dried it in shadow, and then made a fine powder of it using a mortar pestle. Later on, I extracted it with water and on a magnetic stirrer at a constant temperature of 60 degrees Celsius. I dropwise added 0.001 molar of silver nitrate solution until there was a color change from green to pale yellow. Then the calcination was done and the sample was extracted, which was sent for characterization. I have used various analytical techniques such as FTIR, XRD, SEM, EDS, EDX, AFM. In the the FTIR analysis was done for the verification of the functional group present in the sample. The absorption bands at 1625, 1554 and 1411 that we can see in the graph confirms the presence of the silver nanoparticles. There are various other bands for the absorption which we see. It signifies the presence of the other phytochemicals present in the leaf extract. The another analysis was done, it was XRD, which shows a peak at 220. It indicates the FCC crystal structure of the silver nanoparticles, plus the particle size was determined to be 24.84 nanometers. The next analytical technique that was done was SEM. In the SEM, the morphology of the silver nanoparticle has been studied, and we can see there are various, the shape of the silver nanoparticles was seen to be in spheres, rods, prism plates, needles, etc.
Come to conclusion. Come to conclusion.
The FM analysis was done, plus the EDX analysis was done, and the antibacterial activity was done of both gram-positive and the gram-negative bacteria, in which it was seen that it was highly active, except for Escherichia coli and Pseudoplasm fluorescens. In the conclusion, we see that nature has its own coaching manner with synthesizing the miniaturized functional materials. The silver nanoparticles covers a wide spectrum of the significant pharmacological activities, and cost effectiveness provides the alternativeness to the local drugs. So my focus was the synthesis of the biological of the silver nanoparticles for the usefulness of the humankind and the nature. And I was focusing for a cost-effective, eco-friendly synthesis of nanoparticles. Thank you so much. I am very thankful to my co-guide, Dr. Samreen Farooqi ma'am, and my guide, Dr. Pramila Ghumre ma'am, and also everyone present over here. Thank you for the patience listening.
Thank you. Thank you, Amruta. Any question? Okay. For extraction, madam, for extraction, have you tried any other solvent?
For the extraction of nanoparticles?
For extraction of this plant.
No, ma'am. I specifically extracted it with water, but my co-guide has suggested to try a different. So I will try to do it with acetone or chloroform maybe in future.
Okay. Okay, thank you. Thank you, Amrita.
Thank you, ma'am.
Now, the next participant is Shaida Khan. Shaida Khan. Shaida Khan.
Yes, ma'am. I'm present.
Yeah.
Am I
So,
am I audible, ma'am?
Yeah, yeah. Share your PPT.
One second, ma'am. Is my PPT visible, ma'am?
Yeah. Proceed now.
Okay. Good afternoon, everyone. Here, Shaida Khan. I'm doing research under the
Shaida, you have to observe the time.
research.
On Shaida, please listen. You have to observe the
Sorry,
time.
ma'am.
You have to observe the time. 5 minutes.
Yeah.
5 minutes is only allotted. So please start.
I have to present it in 5 minutes.
Yeah, you can proceed.
Okay, ma'am. Three-tier shell for effective conversion of malachite green dye from synthetic wastewater. Its kinetic, isotherm and thermodynamics studies. Here is my presentation flow. I will not take much time into the introduction because we all know that water pollution is one of the major concerns for water pollution. For my research is dyes, because dyes are the visible and has many drawbacks and effect on the humankind as well as animals. There are various methods for the treatment. I am not going to all, but I would like to specifically focus on what I am doing in my research work. That is adsorption. Adsorption is a surface phenomena. We all are aware of it, and we have two parts in adsorption: adsorbate and adsorbent. So advantages is that it has low cost, it is rapid, simple, and much easily available for the work. Various adsorbents has been used. I'm not going on that. The focus is that to cut off the cost, we are using the low cost alternatives of the adsorbent. Here are various low cost. I'm taking agricultural waste. I'm not going on that. The dye I have chosen for my research has drawbacks on for the humans, as it is used in for the dye for detection of thief in it has also many harmful effects which can be seen here. Various methods has been already employed and I am using one of them. So coming to my work, for the treatment of adsorption, we are using other different methods. The first method is physical treatment, where washing, drying, crushing, and sieving is done. The chemical method, we modify the adsorbent chemically by using different methods. Here I am using my adsorbent. I have taken jubilant CJ from the local market. I washed it, dried it, grind it, sieved it, and got the powder of the jubilant CJ. This was then chemically modified by adding this specific amount into the solution of ferric chloride and ferric chloride of NaOH to maintain the pH of the solution. It was then magnetically stirred for about 6 hours and then washed through distilled water thoroughly to neutralize the solution, and then dried and got the magnetized Julius Regia as mentioned NGRS. Has been prepared, that is SAM, ADX, BET, TGA, DTG, XRD, and FTIR. SAM is used to check the surface morphology of the adsorbent. Here figure A shows that the pore sizes and is become smooth after the adsorption of MG dye as shown in figure B.
Your voice is cutting.
Metal analysis in figure A. In figure C, we can show that carbon, oxygen, and nitrogen iron and some amount of calcium and nitrogen, calcium and sodium is present, which after absorption decomposition has been changed and incorporated chlorine, which successfully shows that the malachite green has been absorbed. FTIR is done to get the various functional group present in the variant functional groups.
Come to conclusion. Come to conclusion. Shaida, come to conclusion. Come to conclusion directly.
Our batch, by doing batch studies, I have found that the magnetized Julius regia is a competence prospective adsorbent. It has given the maximum adsorption, maximum removal the pseudo second order kinetics. It has the maximum capacity of monolayer capacity of 150.338 gram mg per gram at 308.15 Kelvin, and the isotherm model best fitters was accompanied by negative value of enthalpy gives free energy, which indicates an exothermic and spontaneous adsorption process. Moreover, the reasonable good regeneration ability of MGRS up to 82.04% was noted up to 5 time adsorption cycle with little degradation. Here are the references. Thank you. Any questions? I'll be glad to answer.
Thank you, Shahida. Any question? Shahida, which agricultural waste have you used?
Sorry, ma'am?
For preparation of adsorbent, which agricultural have you used? Whether it is from maize, cotton,
Sorry, ma'am?
or straw leaves. For preparing adsorbent, which agricultural waste have you used?
Sorry, ma'am, I'm not getting your
Okay, it's okay. Okay, thank you, Shahida.
question. I think there's an technical issue.
No, it's okay. Thank you,
I'm
Shahida.
not getting.
Okay. Now the next participant
Thank you,
is Shivani Sharma. Shivani Sharma is there? Shivani? Okay. Shivani? Is Shivani there? Okay. Now, the next participant is Sayyid Muhammad Shoaib. Sayyid
Good afternoon, ma'am.
Muhammad.
I'm here. I'm audible?
Yeah. You're audible. Please share your slides.
Okay, ma'am. Okay, thank you.
Please do it fast.
My slide is seen. I'm
Yes.
audible?
Yes.
Okay, now I'm presenting my...
Yeah. You can proceed.
Okay, thank you, ma'am. Studies on morphological characterization of characterization and different chemical analysis method for the study of air pollutants. The abstract is the paper report the different morphological characterization and different chemical analysis method like HPLC, GC, MS, laser-based photoacoustic spectroscopy, absorption spectroscopy, Rayleigh scattering, mass scattering, Raman scattering, SEM, EDX, and so on. For the characterization of air pollutant like N2O, SO2, CO2, CH4, NO2, NOx, HNO3, NH3, PM2.5, PM10, and O3, like that. The different types of characterization techniques are listed below. SPLC and whatever I discussed in before. This is the description of the each the technique and characterization method for characterization of air pollutant. What we are doing, what we are done in review study. I am going to finally on material and method. The characterization of air pollutant with this table, it is shown that high performance liquid chromatography is characterized VOCs, volatile organic compounds, and gas chromatography is NOx, SO2, NH3, VOCs. Absorption spectroscopy can characterize air pollutant CO, CO2, CH4, NOx, VOCs, NO2. Like that, Rayleigh scattering is not available for the characterization of air pollutant. Mass scattering PM2.5 and PM10 is to be characterized. Raman spectroscopy can characterize NO2, SO2, PM and VOCs. Similarly, you can see in the table, largely laser-based photoacoustic spectroscopy (LPAS) is sufficient for all the characterization of air pollutant, which is present in the air pollution: NO2, N2O, CH4, NOx, SO2, CO2, CO, HNO3. Discussion part is here. We can see the table for the discussion part. In this table, we can compare the characterization techniques for the different air pollutants and their advantage and disadvantage. In this table, we can see the which technique is best for the characterization for the air pollutant. From this chart, we can conclude that in the conclusion, among all the above characterization techniques discussed above, laser-based photoacoustic technique is the most suitable for the many air pollutants like NO2, NOx, SO2, CO2, CO, CH4, NH3, and so on. This popular technique is a multi-component, portable, calorimetric, high sensitivity, selectivity, easy to handle. In this characterization technique, there is no need of much separate time for sample preparation, suitable for liquid, solid, and gas sample, but separate chamber need for the different states. Thank you.
Thank you for your presentation. Any question? Okay. Now we will proceed for the next presentation.
Okay, ma'am.
Yeah. Next presenter is Walid Ahmed. Walid Ahmed. वालिद अहमद है क्या ऑफलाइन ऑनलाइन ओके नाउ द नेक्स्ट प्रेजेंटर इज जिशान अहमद जिशान अहमद या start with your presentation.
Is my slide visible?
Yeah. Yes, start with your presentation.
Good afternoon, everyone. Myself, Session Ahmed from Department of Applied Chemistry, am your leader. Feeling privileged to present you today the insight of my presentation on the topic novel magnetic graphene oxide and alginate-based double network hydrogen for efficient maleic ring removal, development, characterization, and superparamagnetic separation in wastewater treatment. Here are the table of the content which I will be covering in my slides, which is introduction, adsorbent synthesis, adsorbent characterization, its gas absorption studies, isothermal and thermodynamic analysis, kinetic and absorption studies, result discussion, conclusion and future plans for differences. I will be skipping all the introduction part as I will be knowing that it is very difficult to cover the whole introduction, as you all know that environmental pollution is one of the serious concerns increasing at an alarming rate since the start of industrialization rapid growth of mankind. And these are the different type of water pollution which are happening day by day. So what are the treatment method actually I will be using is adsorption treatment method. Theoretical introduction of that method is given here. And in that adsorption, there are two types, which is physioadsorption and chemical-adsorption. In my research, I have been covering both of that. These are the factors which will be influencing the adsorption, which is surface area, and other are the steps which I will not be discussing here. And these are basically the type of interaction which are responsible for that removal efficiency of those adsorbents on that topic. And these are the steps which happens during the adsorption process, which covers in the adsorption context. These are the techniques which I will be using for characterizing my adsorbent, which is SEM-EDX, STEM, SAI, BET, XRD, VSM, TGF, TIR. So whatever hydrogel I have synthesized, I have characterized with the help of XRD, in which all the three components which I have used, graphene oxide and iron oxide particles and sodium alginate, all are present, which are visible through XRD analysis. And FTR analysis also shows the complex structural functionalities which are responsible and for the effective adsorption. That analysis shows the higher surface area, which comes out to 153 meter square centimeter cube per gram, and VSM analysis shows the super paramagnetic behavior of the adsorbent. With the help of SEM and EDX analysis with elemental mapping, plots of the elemental composition, the structural component of the adsorbent has been clarified. With the TEM analysis, we have seen the fine structural aspect of the adsorbents, which has been mentioned here. With the TGA, the thermal stability of the adsorbent has been seen and has improved from the former graphene oxide and sodium alginate because of the incorporation of iron oxide nanoparticles. And the batch adsorption studies has also shows the reasonable good adsorption capacity and removal efficiency. And adsorption studies has shown the sodium hydrogen carbonate as the absorbing agent. This is the proposed adsorption mechanism, which I have seen that hydrogen bonding, Yashoda hydrogen bonding, and pi-pi interaction and electrostatic interaction are the main interactions responsible for the removal of the pollutant. The result and discussion is further, the same things will be coming here. The conclusion is that it has shows the good number of active adsorbing sites, enhancements in the porosity because of the introduction of the sodium alginate in the graphene oxide and iron oxides, and increase in the surface area and generation of the new functional group has been seen. And with this, further advancement can be possible in the future prospect. And these are the references for the work I have covered. Thank you for.
Thank you for your presentation. Any question? So thank you, Ahmed. Now the next participant is Abu Taha.
Hello, yes ma'am, can you hear me?
Yeah, you are audible.
Okay.
Now share your slides.
Okay. Is it visible, ma'am?
No. Yeah.
Is it?
Yeah.
Okay.
Now it is visible.
So I'm presenting my poster based on SIG-based metal complex for reduction of aromatic nitro compounds. So here in introduction, we know already the SIG-base are the compound formed by condensation of aldehyde and amine. So these are used in medicine and other parts of chemical industry as catalyst as well. So here aromatic nitro compounds are pollutants which are released in water. So it is necessary to convert them into less harmful amines. So in experimental design, we have synthesized a SIG-base by 2-amino-4-chlorophyrol with condensation of 1,4-benzene dicarbaldehyde, and the same SIG-base is used for the preparation of copper complex. These are the result like FTIR and FTIR mass NMR of the SIG-base ligand, and these are the UV which confirm the synthesis of SIG-base ligand as well as the metal complex. These are the elemental analysis ADX and as well as FTSEM of SIG-base and metal complex. And in catalytic study, we have reduced 3 aromatic nitro compounds that are 4-nitrophenol, 4-nitroaniline, and nitrobenzene. So we have monitored their reduction by using UV technique. Here the rate constant was determined by assuming pseudo-first order kinetics where the rate constant of all three pollutants were determined like a 1.7 minute inverse for these three aromatic nitro compounds. So in conclusion, we synthesized a SIP-based complex which we used for the conversion of aromatic nitro compound into less harmful aromatic amines.
Thank you very much for your presentation. Is there any question? Thank you, Abu.
Thank you.
Walid Ahmad is there? Walid Ahmad? He has not presented. Ahmad. Shivani Sharma? Is Shivani is there? Shivani is there? Shivani Sharma and Walid Ahmad. Okay, thank you. So total 8 presenters were there. So, you want to conclude? So we will conclude this session.
So we are going to conclude the session, but this is not the end. After this session, we have the validity session, and we will continue it till 5 p.m. So if there is any participant who was not able to present the presentation, if anyone wants to present their presentation, he can join the link. They can join the link and ask for presentation. If there is anyone participant who was not able to present their papers or presentations, if they are able to, if they want to present their presentation, they can come and present their work. There is no one absent, and those who are absent, they are not able to connect us. And now I was also enrolled as a participant, but I was not able to prepare my slides, and I just want to give some concepts, and just I want to summarize that what I am doing in my research, and what actually I have synthesized, and what we are going to synthesize, and whatever the results I'm showing here are not complete yet, but we are working on it. The work is under progress. So I am Ansar Jahan. I'm doing my PhD under the supervision of Dr. Sayyid Salahuddin sir. This is my title of research is Camarine derivatives. Actually, we want to synthesize the different derivatives of camarine. As you all of know that camarine is a heterocyclic compound with a benzopyrone ring, and it has a number of biological application. Doing this idea that the camarine has a number of biological application, we are working on it, so that as we all of know that the camarine has biological application like anti-cancer, antiviral, antibacterial, anti-inflammatory. So here is my work. We actually want to synthesize the acid derivatives and ester derivatives of camarine. So the first step of the synthesis is we are taking the resacinol and ethyl acetoacetate in presence of acid catalyzed it's acid catalyzed reaction. We have prepared the 7-hydroxy-4-methylcoumarine and the conformation of this compound 7-hydroxy-4-methyl is done by the TLC, and then after the mass we have mass for it, and also the proton NMR. So the next step is after the synthesis of this 7-hydroxy-4-methylcoumarine, we just couple this 7-hydroxy-4-methylcoumarine with fluorobenzoic acid. This fluorobenzoic acid is get coupled with 7-hydroxy-4-methylcoumarine with the this ether linkage, and after that then we are coupling it with the different alcohols, either aliphatic or aromatic alcohols. Then we get the ester derivatives, and in this work we are trying to use these ester molecules, coumarine ester derivatives, as a biomarkers. So we are working on this. So this is all about my research. So thank you so much. If anybody want to ask any question regarding my title and regarding my research, so please. What, ma'am? Mass. Actually, we have a private lab in Hyderabad. Yeah, so we are doing the mass there. Yes, ma'am. So our Dean sir is here. So I would like to thank Ma'am Rashmi ma'am. Ma'am, thank you so much for giving us that much time. So I would like to our Dean sir, Professor Salman Ahmad Khan sir, to present a memento to the Professor Rashmi ma'am. Please, sir. Have a big hand for Professor Rashmi ma'am.